Right, well, the net of a shape is what you get if you take a three-dimensional shape like this cuboid here and imagine peeling the sides down so that you can lay it flat on the surface. And that's what they want you to do when they want you to draw a net of that cuboid. So with this one, they've already drawn the base for you. So the base is 6 centimeters by 3 centimeters. That's there. So if you imagine that this is going to come down, this front face here will be drawn there. So it's going to be 6 centimeters by 4.5 centimeters. So 4.5 centimeters will take us to there. So that's the front. Then we have the side, and the side is going to be 3 centimeters, which is there, and when that drops down you can have 4.5 centimeters going this way, and similarly for the flap on the other side, additional 4.5 centimeters going that way. Alright, so what we have now is the base, which was there already, the front and the two sides. We now have a back, which is going to be the same dimensions as that. So that's going to be 4.5 centimeters this way. So there's our base, front, back, two sides. Finally, this is a cuboid, so it's going to have a top to it as well. And the top is going to be the same as the bottom. It's going to be 6 centimeters by 3 centimeters. And that could go there or beneath. It doesn't matter. So that's going to be 3 centimeters. There and there. So that would be the accurate net of that cuboid. If you imagine folding that up, that would come to the front, that would be the back, that would fold over along the top, and then those would come up the sides. It's not the only net, because that could have been attached to one of the sides, but it's certainly probably the most logical one to fit into that space. Okay, here another net question. This time we have to draw an accurate triangular prism. Again, the base has been drawn for us. So what we're going to have on the sides here is this triangular face. So it's going to come out 3 centimeters at a right angle there, and the same on this side. So that's the base and the two sides. It's going to have a back flap on it, which is going to be 3 centimeters going that way. So if you imagine folding that up now, you've got the base, you get the two sides and the back. So the last thing we need is this diagonal surface here, and the most room to fit that in would be beneath here. So what we need now is a 5 centimeter side coming down here. So that should do it. Let's just check, make sure we're happy. The base was drawn for us. This side will fold upwards and create this side here. That side will fold upwards and create the opposite end. This will fold upwards and create the back to the triangular prism, and then this will fold towards the base to form the sloping face. Now with the third question, they haven't started for us, so we're free to draw this one as we wish. It's 6 centimeters long. It's going to have a rectangular base, so if I draw the rectangular base 6 centimeters, it's going to be 2 centimeters wide. So that will be the base of my prism. Then I've got an equilateral triangle on each side, which is 2 centimeters by 2 centimeters. So there's one side. There's the other triangular side. And now we're going to have another 2 centimeter side coming up there. So that will fold up the back and line up against that triangular side there. And similarly another 2 centimeter one to fold up to give the front part of the net of the prism. So that will give you the net of the triangular prism. And the final question that I've managed to find on nets is question 4. And what we're doing in question 4 is matching up these nets with the 3 objects that we have on the right hand side of the page. So what we want to do is for the cuboid, which is number 1 there, find which one of those shapes would fold up to give it. I think it's fairly clear that that is going to be C, as there's no way anything else will create that shape. The second one, which is got 3 triangular faces, well, the only one there which has only got triangular faces is E. So if that was our base, you can see that the other 3 triangles will fold up to give the second shape there. So that is net E. And finally, we've got 2 triangular sides with other rectangular faces. So that's a triangular prism, and that's going to be B. And I've kept question 5 on. This is even rarer than nets. The key word here is congruent. Which of the above triangles are congruent? Well, congruent is a mathematical word which means identical. So you're looking for triangles which are absolutely identical in size and angles, and hopefully you can see there that the 2 that are identical would be B and F. So the 2 congruent triangles in that shape, in that selection.